even know. Here is one of my drawings of the circuit of the Schlatter SWEP05 operator panel. Now, to turn on the 7-segment displays, this IC right here is used. There's 5 in that panel. Their part number ICM7218C IPI. That C is very important. To determine which of the 8 7-segment displays the data is sent to, we have a digit address, DA0 on 5, DA1 on pin 6, DA2 on pin 10. And that 0 through 7 determines which segment the character is sent to. The characters are determined from ID0, ID1, ID2, ID3, and ID7. That's input data 0, 1, 2, 3, and 7. Input data 0 is on 12, input data 1 is on 11, input data 2 is on 13, input data 3 is on 14, and up here this is for the decimal point, whether we turn it on or not. When this input data 7 is low, the decimal point is turned on. When input data 7 is high, the decimal point is turned off. Here is a 74HCT244N, and it is a buffer between this ribbon cable connector labeled N1 on the board and the ICM7218C. We can see that the outputs are always enabled on the 74HCT244N because they're output enable. A and B on 1 and 19 are tied low. The ribbon cable, ID0, is on pin 17 of that ribbon cable. ID1 is on 19. ID2 is on 14. ID3 is on 13. DA2 is on 22. DA1 is on 20. DA0 is on 18. And ID7, input data 7, is on 12. Now down here, pin 9, that has 3 functions. If pin 9 is tied high to 5 volts, then the data sent to those 7-segment displays is hexadecimal. If, as in our case, pin 9 is floating, not connected high or low, then we are in BCD mode, code B mode, binary coded decimal. If pin 9 is tied low, then that device is in shutdown mode, turned off. In our case, we are sending binary coded decimal out to the 7-segment displays based upon whether we have 0, 0, 0, 0 or 1, 1, 1, 1 and all the states in between. Let's go to the next page. Here are the 5 ICM7218C IPI ICs that drive those 7-segment displays and LEDs. When we select which digit address, which 7-segment display we want to send the data to, and we put the selection of that data 0000 or through 1111 on the input data pins. When we drive this input low, it'll be high to start out with. When we drive it from high to low, back to high, that data is applied to that 7-segment display. And we have IC1 through IC5. Let me put, if I can get it in there, here's IC1, IC2, IC3, IC4, and IC5. Let me put this in here real quick. Now IC1, can y'all see that okay? IC1 controls this 7-segment display, this one, this one, this one, this one, this one, and this one, and this one. So we have 1, 2, 3, 4, 5, 6, 7 segments controlled by IC1. Here, IC2 controls these segments. IC3 controls these 7-segment displays. IC4 controls these 7-segment displays. And IC5 controls these. Now if I missed a couple of segments, maybe didn't draw them all out, but there we go. So IC1, IC2, IC3, 4, 5, and down here 1. Let's go back. There's an MC74HC154N. And its purpose is to drive these right inputs on pin 8 of each ICM7218C low and then high again. In order to do that, only one output is driven high to low to high, and that's based upon the address inputs and the input enable. We have 2 input enables, and they're not to be confused with the output enables. These are input enables according to the data sheet of this IC. Now input enable 1 on pin 19 is tied to ground, so that's not being used. It's already asserted low. Input enable 0 on 18 is controlled through this buffer IC 74HCT244N on pin 29 of this ribbon cable. The addressing of these ICs right here is done on these pins right here. And again, we have buffering, and they come out on the ribbon cable connector. I labeled them right address 0 on the ribbon cable pin 24, right address 1 on pin 26, right address 2 on pin 28, and right address 3 on pin 27 of that ribbon cable. So let's say we wanted to write to IC1. Well, it is connected to Y0 bar. So if I set all these inputs to 0 and I pull input enable 0 low, then this output right here will go from high to low. When I place the input enable on 18 back to high, this output will go from low to high, thus writing that data to that selected 7-segment display based upon the input data and the digit address that we have already set up. If I wanted to write, for instance, to IC5, down here Y4 on pin 5 is connected to write address on IC5. So here, let's go through the sequence. We have 0000 for this IC. We have 0001 for this IC. We have 0010 for this IC. 0011 for this IC. And 0100 to write to this IC right here. There's a lot going on there. It's confusing. I even confused myself for a little bit. So we set the write address to select which ICM7218C that we're writing to, and then we drive this input enable low, from high to low to high. Now down here on the ribbon cable, 5 volts is applied to 3 or 4 and ground on 1 or 2 from an external 5 volts DC power supply. Phew! That's complicated. And we ain't even halfway through. Alright, folks. We'll get this one done yet. The fascinating part of this was that we were able to connect and write some code to test that operator panel. Now be patient. We'll see the code shortly. We got a little bit more theory to go through. Might do that tomorrow. We'll see. Hold on. Evening all. We got to hurry up before the sun goes down. Here's day 2 of video number 3. We're going to talk about the function of ICM7218C. Now, here on pin 5 is digit address 0. On pin 6 is digit address 1. On pin 10 is digit address 2. Those select which 7-segment display is operated on, which 7-segment display will display the character that we set up with input data 7, the decimal point. This input determines whether the decimal point is on or off. That's on pin 7. Input data 0 is on pin 12. Input data 1 is on pin 11. Input data 2 is on pin 13. And input data 3 is on 14. And we'll go through the chart here in a little bit on which characters are displayed based on the data applied to these 4 inputs right here. 0, 0, 0, 0 through 1, 1, 1, 1. When we have the character set up on the input data, we select which digit is turned on, and that would be 0, 0, 0. And if we have 0, 0, 0 on the digit address, this pin right here, 15, goes high. And that applies 5 volts to the 7-segment character anode, the common anode input on digit 1. As for instance, if our next value is 0, 0, 1, then this 7-segment display's common anode will be turned on. 16 will go high. Now if we had 0, 1, 0, this digit up here, this 7-segment display tied to pin 23, the common anode of that 7-segment display, would go high. This device can control 8 7-segment displays. Here's on 15 is the 7-segment display, digit 1. On 16, the 7-segment display on digit 2. Up here on pin 23, digit 3, the 7-segment display. Common anode connected to these digit pins. Here's digit 4 on pin 20, the common anode of that 7-segment display tied to pin 20. On 17, there's digit 5, the 7-segment display's common anode of that 7-segment display. And digit 6 on 22, digit 7 on 21, and the last one, digit 8 on 18, the common anode of that 7-segment display. So 8 7-segment displays can be controlled with this IC right here. Now there's another version of this IC that's common cathode, and I believe, I'll have to look at the data sheet, or y'all can look at the data sheet, I believe that's the A and the B version, not the C nor the D. Here are the segments, and I've got the segment drawn here in the middle. Here's segment A, B, C, D, E, F, G, and the decimal point. All 8, if there is 8 in that bank, are paralleled. The segments are paralleled. So here on 4 is the decimal point. On pin 27 is segment A. On pin 3 is segment B. On pin 1 is segment C. On 25 is segment D. On pin 2 is segment E. 24 is segment F. Where's the last one? 26, segment G. So the segments of all 8 characters are parallel. If we drive this first digit, this first 7-segment display high with the digit address of 000, and say for instance we wanted to make the character 7, we would drive A low, that's 27, B low, that's pin 3, and C low, that's pin 1. And we would have the number 7 displayed in that 7-segment display. Let's look at the characters. Oh, I'm getting sidetracked here. In order to do so, we have to drive pin 8 from a high of 5 volts, low and then back high. And that character would be displayed on that 7-segment display. Now let's look at the chart that determines the character that we display on the selected 7-segment display based upon the input data. Alright, I'm going to have to move the camera up so y'all can see that and get closer. I don't know if you can see that, so I'm going to go through it with you. Here's input data 0, input data 1, input data 2, and input data 3. It's getting dark outside. We might have to do this tomorrow. So if we have all zeros and pin 9, the mode pin is floating, so we're in code B mode. If we were to tie pin 9 high, we would have this column to go through, but we're in code B mode. Pin 9, the mode pin is floating. So all zeros, 0, 0, 0, 0, we have a 0 on the output. When we have 0, 0, 0, 1, we have 1 on the output. 0, 0, 1, 0, we have 2 on the output. 0, 0, 1, 1, we have 3 on the output that's sent to be displayed on the segments. We have 0, 1, 0, 0, we have a 4 displayed. 0, 1, 0, 1, 5 is displayed on that selected character, on that selected 7-segment display. 0, 1, 1, 0, 6 is displayed. 0, 1, 1, 1, 7 is displayed. 1, 0, 0, 0, an 8 is displayed on the selected 7-segment display. 1, 0, 0, 1, a 9. And here's where we differentiate a little bit. Binary coded decimal is 0 to 9, but they've added a few more. So 1, 0, 1, 0, that's a binary 10, we have a dash. 1, 0, 1, 1, we have an E. 1, 1, 0, 0, we have an H. 1, 1, 0, 1, E is displayed on that selected 7-segment display. 1, 1, 1, 0, a P is displayed on that selected 7-segment display. And lastly, 1, 1, 1, 1, the 7-segment display is blank. No segments are illuminated. Well, there we go. I hope I was able to explain that function of that ICM 7218C. Now, lastly, we have to discuss the code that I used in my universal input-output board centered around the PIC 16F877A. Here's where we get to the fun part when we talk about the code. I like doing it. But did you see the process? Before we write the code, we had to reverse engineer that Schlatter SWEP05 operator panel. And then we had to pull up the data sheets on the ICM 7218C to understand how it works. And then lastly, when all of the hardware is understood, we wrote the code to interface to that hardware and test it with our code and hardware. Nice. Okay. Next video will be the code. You're going to like that one. It's very, very compact. And maybe it'll get you into programming code to interface hardware to different items that you test. Either way, if you like to work on the hardware or work on the code, It's a good line of work to get into. And when you can put hardware and code together, or code and hardware, it's a mind-blowing world. Okay, stand by for video number 4, and we'll talk about the code. Good night all. We got some fish to fry up. Y'all have a good day. Enjoy the time on this side of the dirt. We'll see you next time.